Hi there, I'm Phil Estes from IBM's Cloud Unit. I'm a maintainer in the Docker and Containerd communities. And I'm going to talk to you briefly about container runtime performance, a project I'm working on in the context of the serverless use case. So we all know about servers. We've been, for a couple decades, been trying to figure out how to deploy our applications in better and better ways onto servers of all stripes and ways and technologies. Along came virtualization and kind of changed our world. Since then, we've kind of come up with this cloud concept and all these programmable layers like IaaS and PaaS. Containers kind of shifted that whole thinking again in new ways. But then this happened. Tim Wagner, the AWS Lambda lead, smashed a physical server on stage for dramatic effect at Serverless Conf in New York City last year. But we all know the truth. It was mentioned here this morning. Guess what? There are still servers. It just so happens that you don't run them anymore, but someone's worrying about the operational aspects of them. You just have to focus on your functions, registering them with a provider, setting up triggers and actions so that they run when you want them to. But these servers actually matter because you've been given a bunch of expectations from the provider about your functions having sort of this infinite scalability, perfect uptime, and all these things that you only want to pay when your functions run. And so these providers are having to consider how they're operating these servers running your functions because you're only paying at sort of 100 millisecond increments, and this execution time is very important for those that are running those servers. The pricing that most of these providers are going to offer you is in this new term, gigabyte seconds. It's the time that my function runs times the memory allocated for my function gives me this gigabyte seconds. And so the people running those servers, it's important to them, whether it's Microsoft or AWS or Google or IBM's OpenWhisk project, they're all having to care about how to operate these servers in the best possible way. The one I know the most about, of course, being from IBM, is our OpenWhisk platform. It's both an open source project that's been contributed to the Apache Foundation. We also operate it as a service in IBM Bluemix. And of course, I've been helping that team with this concept of performance. Our architecture, the invoker, it just made the most sense to us to use containers for running your function. But we don't really need the entire concept of a complete container ecosystem. What we really need is predictable and scalable start, stop, pause, and unpause. There's a lot of other things that a container engine might give you: image management, orchestration, maybe some complex networking, plugin support, but really we just want that single important factor of speed. And so in our use case, maybe the Docker engine is really overkill for this scenario. Well, the good news is that there are options. There are obviously other container providers, but Docker themselves have been splitting up the engine into various components like runC from the Open Container Initiative, Containerd, which is a new project that I'm maintaining. But these have different characteristics, and what we want to know is, among these, which is going to provide the best capabilities to run your functions as a service in the most performant way. We don't have time to get into all the differences, but I wrote a project because, first of all, one of the things that we want to do is understand what's the operational throughput of these different layers. So I created a project bucket bench. You can go check it out on GitHub. It's not just that we want to know the operational throughput, but as we add load, what's the stability of these various engines under significant parallelism? How are they each performing under different characteristics, like the network or different storage underneath it, different Linux kernels? And so this project is used to do that, but we don't want to just know which one is faster. We want to know why. And so we've used a lot of other tools, even including strace and flame graphs, to understand why is the Docker engine slower and runC faster here and not there. And so at this point, we're still continuing this work. runC has clear kind of straight line performance advantages over a full functioning engine. We found some Linux kernel issues that we're going to the kernel community about. What can you do? I'd love for you to check out the Bucket Bench project. Connect with me if you have interest in this area or questions, and most of all, have fun with containers, whatever you're doing with them. Thank you very much.